Section 370.28N of the National Electrical Code, or NEC, does not apply to street lighting pole boxes located in the right-of-way and away from private property. This section addresses raceways installed in or on buildings or structures. It mandates sufficient spacing to ensure adequate access for maintenance and repairs. However, this requirement is specifically not applicable to raceways situated in the right-of-way, removed from private property. Therefore, conduits are not required to be spaced 6 times the diameter of the largest conduit within street lighting pole boxes that are in the right-of-way and away from private property. The 6 times diameter spacing rule, as defined in Section 370.28N, is only relevant to raceways that are installed within or on buildings or structures, and not to raceways found in the right-of-way, away from private property. To understand this more deeply, it is essential to examine the specifics of Section 370.28N and its context within the NEC. The NEC is a comprehensive set of standards and guidelines designed to ensure the safe installation and operation of electrical systems. It is regularly updated to reflect new technologies and best practices. Section 370 pertains to pole boxes, junction boxes, and hand-hole enclosures. These are enclosures used to provide access to electrical conductors for pulling, splicing, or maintenance purposes. They are critical components in electrical systems, allowing for flexibility and ease of access in wiring installations. Section 370.28 specifically addresses the installation and construction requirements for these enclosures, focusing on aspects like their support, the entering of cables and raceways, and the spacing around them. The purpose of Section 370.28N is to ensure that when these enclosures are installed in or on buildings, they are positioned in a way that allows electricians and maintenance personnel to easily access them for any necessary work. This includes having enough space around the enclosure to open it, work inside it, and run new cables or raceways as needed. The 6 times diameter rule is a specific requirement for spacing that is intended to provide ample working space around raceways entering these enclosures. Raceways are channels designed to hold and protect electrical wires and cables. Common types of raceways include conduits, electrical metallic tubing or EMT, and cable trays. The diameter referred to in the rule is the outer diameter of the raceway. So, if the largest conduit entering a pole box has an outer diameter of, for example, 2 inches, the rule would require that there be at least 12 inches of clear space around that conduit. This spacing is meant to prevent overcrowding and to make it easier to work on the electrical system without having to move or disconnect other components. However, the NEC recognizes that the requirements for electrical installations in public rights-of-way can be different from those in or on buildings. Rights-of-way are areas of land that are set aside for public use, such as roads, sidewalks, and utility corridors. Street lighting is often installed in these areas to provide illumination for public safety. Because these installations are typically outdoors and not directly attached to buildings, they are subject to different environmental conditions and maintenance considerations. One of the key differences is that there is often more open space available in rights-of-way compared to inside buildings. This means that it may not be necessary to enforce the same strict spacing requirements that are needed to ensure access in confined spaces within buildings. Additionally, street lighting pole boxes are often designed to be more robust and weather-resistant than those used indoors, and they may be subject to different inspection and maintenance schedules. Therefore, the NEC makes a distinction between raceway installations in buildings and those in the right-of-way. This distinction is reflected in the fact that Section 370.28N specifically applies to raceways installed in or on buildings or structures, but not to those in the right-of-way. In the case of street lighting pole boxes in the right-of-way, other sections of the NEC may apply. These sections might address issues such as the support and grounding of the enclosures, the protection of conductors from physical damage, and the prevention of water from entering the enclosures. It is important to consult the relevant sections of the NEC to ensure that street lighting installations in the right-of-way comply with all applicable requirements. Now let's delve deeper into the specific aspects of this interpretation and its implications for electrical installations. Firstly, it's important to define what constitutes a right-of-way in the context of electrical installations. A right-of-way typically refers to a strip of land that is owned or controlled by a government entity or utility company for the purpose of providing access for public infrastructure, such as roads, sidewalks, and utility lines. This can include areas along streets and highways, as well as easements across private property that have been granted for the installation and maintenance of utilities. The distinction between installations in the right-of-way and those on private property is significant because it reflects the different regulatory environments and practical considerations that apply to each. Installations on private property are typically subject to the oversight of local building departments and must comply with all applicable codes and regulations. In contrast, installations in the right-of-way may be subject to additional regulations imposed by the government entity or utility company that controls the land. These regulations may address issues such as the location and depth of underground utilities, the need for permits and inspections, and the requirements for traffic control and public safety during construction and maintenance activities. Secondly, it's important to understand the reasons why the NEC makes a distinction between raceway installations in buildings and those in the right-of-way. As mentioned earlier, one of the key reasons is that there is often more open space available in rights-of-way compared to inside buildings. This means that it may not be necessary to enforce the same strict spacing requirements that are needed to ensure access in confined spaces within buildings. Additionally, street lighting pole boxes and other electrical enclosures in the right-of-way are often designed to be more robust and weather-resistant than those used indoors. They may also be subject to different inspection and maintenance schedules, which can affect the way they are installed and maintained. Another important consideration is that electrical installations in the right-of-way are often subject to different environmental conditions than those indoors. They may be exposed to extreme temperatures, moisture, sunlight, and other factors that can affect the performance and longevity of electrical equipment. As a result, the NEC may have different requirements for the types of materials and methods that can be used in these installations. For example, the NEC may require that conductors in the right-of-way be protected from physical damage by being installed in rigid metal conduit or other approved raceways. It may also require that enclosures be made of corrosion-resistant materials to prevent them from rusting or deteriorating over time. Thirdly, it's important to consider the specific requirements of Section 370.28 and how they apply to raceway installations in buildings. This section states that raceways entering pole boxes, junction boxes, or handheld enclosures must be arranged so that there is sufficient space to access the conductors and make connections. The 6 times diameter rule is one way to comply with this requirement, but it is not the only way. The NEC allows for other methods of providing adequate access, as long as they are approved by the authority having jurisdiction, or OJ. The AHA is the entity that is responsible for enforcing the NEC in a particular area. This could be a local building department, a state electrical board, or another regulatory agency. The AHA has the authority to interpret the NEC and to make decisions about whether a particular installation meets the requirements of the code. In the case of raceway installations in buildings, the AHA may allow for alternative methods of providing access if they determine that the 6 times diameter rule is not practical or necessary in a particular situation. For example, the AHA may allow for a smaller spacing between raceways if there is sufficient working space around the enclosure and the conductors can be easily accessed for maintenance and repairs. Finally, it's important to note that the NEC is not the only set of standards that may apply to electrical installations in the right-of-way. Other standards, such as those issued by the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Safety Code, or NEC, may also be relevant. The IEE develops standards for a wide range of electrical and electronic equipment and systems. The NEC is a widely recognized standard for the safe installation and operation of electrical power and communication systems. It is often used by utility companies and other organizations that operate electrical infrastructure in the right-of-way. In summary, Section 370.28 of the NEC does not apply to street lighting pole boxes in the right-of-way, away from private property. The 6 times diameter spacing requirement in this section only applies to raceways installed in or on buildings or structures. When installing electrical equipment in the right-of-way, it is important to consult the NEC and other applicable standards to ensure that the installation complies with all relevant requirements. Furthermore, it is essential to understand the specific requirements of the local AHA and to obtain any necessary permits and inspections before beginning work. Let's further clarify the application of the National Electrical Code, specifically regarding street lighting and electrical installations within public rights-of-way. The NEC is a comprehensive document, and its proper application hinges on understanding the definitions and scope of its various sections. In the context of street lighting, several factors determine which specific NEC requirements are applicable. These factors include the location of the equipment, the type of installation, and the specific components being used. Firstly, let's reiterate the definition of a right-of-way. A right-of-way is a designated area of land reserved for public use, often encompassing roadways, sidewalks, and utility corridors. Electrical installations within these areas, such as street lighting systems, are typically subject to specific regulations that may differ from those governing installations on private property. The NEC recognizes this distinction and provides specific guidelines for installations in public rights-of-way. One key consideration is the type of equipment being used. Street lighting systems typically consist of several components, including light fixtures, poles, conductors, and control equipment. Each of these components must be installed in accordance with the NEC and other applicable standards. For example, light fixtures must be listed and labeled for their intended use, and they must be installed in a manner that prevents water from entering the fixture. Poles must be structurally sound and properly grounded, and conductors must be protected from physical damage and environmental factors. Control equipment, such as photocells and timers, must be installed in accordance with the manufacturer's instructions and the NEC. Another important consideration is the type of installation. Street lighting systems can be installed above ground, underground, or a combination of both. Above-ground installations are typically easier to install and maintain, but they may be more vulnerable to damage from weather and vandalism. Underground installations are more aesthetically pleasing and less vulnerable to damage, but they are more difficult to install and maintain. The NEC provides specific requirements for both above-ground and underground installations, addressing issues such as conductor burial depth, raceway requirements, and grounding. Now, let's specifically address the issue of conduit spacing in street lighting pole boxes. As mentioned earlier, Section 370.28 of the NEC does not apply to street lighting pole boxes in the right-of-way. This means that the 6 times diameter spacing requirement in this section does not apply to these installations. However, this does not mean that conduit spacing is not important in street lighting pole boxes. The NEC still requires that conduits be installed in a manner that provides adequate access for maintenance and repairs. The specific spacing requirements will depend on the size and type of conduits being used, as well as the size and configuration of the pole box. In general, it is good practice to provide as much space as possible between conduits in a pole box. This will make it easier to work in the electrical system without having to move or disconnect other components. It will also help to prevent overheating and other problems that can occur when conduits are too closely spaced. In addition to conduit spacing, there are several other factors to consider when installing street lighting pole boxes in the right-of-way. These factors include the following. Firstly, the location of the pole box. The pole box should be located in a place where it is easily accessible for maintenance and repairs. It should also be located away from areas where it could be damaged by traffic or other activities. Secondly, the size of the pole box. The pole box should be large enough to accommodate all of the conductors and equipment that will be installed inside it. It should also have enough space for workers to safely perform maintenance and repairs. Thirdly, the type of pole box. The pole box should be made of a durable, weather-resistant material. It should also be designed to prevent water and other contaminants from entering the box. Fourthly, the grounding of the pole box. The pull box must be properly grounded to prevent electrical shock hazards. The grounding system should be installed in accordance with the NEC and other applicable standards. Fifthly, the labeling of the pull box. The pull box should be clearly labeled to identify its purpose and the voltage of the conductors inside it. This will help to prevent accidental contact with energized conductors. In addition to these factors, it is important to consult the local utility company and other relevant authorities to determine if there are any additional requirements for street lighting installations in the right-of-way. These requirements may vary depending on the specific location and the type of installation. In summary, while Section 370.28 of the NEC does not apply to street lighting pull boxes in the right-of-way, conduit spacing is still an important consideration. When installing street lighting pull boxes in the right-of-way, it is important to consider the location, size, type, grounding, and labeling of the pull box. It is also important to consult the local utility company and other relevant authorities to determine if there are any additional requirements for these installations. Let's elaborate on the specific requirements and considerations that apply to street lighting pull boxes and related electrical installations in public rights-of-way, focusing on practical aspects in compliance with the National Electrical Code. When working with electrical installations in public rights-of-way, it's crucial to understand that these areas often have unique challenges and regulatory requirements compared to installations on private property. The right-of-way is typically managed by a local government agency or utility company, and they may have specific rules and guidelines that must be followed in addition to the NEC. Firstly, let's discuss the selection and installation of pull boxes. Pull boxes are enclosures that provide access to electrical conductors for pulling, splicing, and maintenance purposes. They are an essential component of street lighting systems, allowing for the routing and connection of conductors along the lighting circuit. When selecting a pull box for use in a public right-of-way, several factors should be considered. These include the size of the box, the material it is made of, and its ability to withstand environmental conditions. The size of the pull box should be adequate to accommodate the number and size of conductors that will be installed inside it. The NEC provides guidelines for determining the minimum size of pull boxes based on the number of conductors and the size of the raceways entering the box. The material of the pull box should be chosen based on the environmental conditions in the area. In areas where there is a risk of corrosion, such as coastal areas or areas with high levels of salt in the soil, a pull box made of corrosion-resistant material, such as fiberglass or stainless steel, should be used. The pull box should also be able to withstand the weight of traffic and other loads that may be imposed on it. In areas where the pull box is located in a roadway or sidewalk, it should be designed to withstand the weight of vehicles and pedestrians. Secondly, let's discuss the installation of conduits and conductors. Conduits are raceways that provide a protective pathway for electrical conductors. They are typically made of metal or plastic and are installed underground or above ground to protect conductors from physical damage and environmental conditions. Conductors are the wires that carry electrical current from the power source to the streetlights. When installing conduits and conductors in a public right-of-way, several factors should be considered. These include the depth of burial, the type of raceway, and the ampacity of the conductors. The depth of burial for underground conduits and conductors is specified in the NEC. The minimum depth of burial depends on the voltage of the conductors and the type of raceway being used. In general, conductors should be buried deep enough to protect them from physical damage and to prevent them from being disturbed by excavation activities. The type of raceway used should be appropriate for the environmental conditions in the area. In areas where there is a risk of corrosion, a raceway made of corrosion-resistant material, such as PVC or fiberglass, should be used. The ampacity of the conductors should be sufficient to carry the electrical load of the streetlights. The NEC provides tables that specify the ampacity of conductors based on their size, insulation type, and installation method. Thirdly, let's discuss grounding and bonding. Grounding and bonding are essential for ensuring the safety of electrical installations. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. Bonding connects all metal parts of the electrical system together, which helps to prevent voltage differences that could cause electrical shock. When grounding and bonding electrical equipment in a public right-of-way, several factors should be considered. These include the type of grounding system, the size of the grounding conductors, and the location of the ground rods. The type of grounding system used will depend on the type of electrical system and the local utility requirements. In general, street lighting systems are grounded using a multi-grounded neutral system, in which the neutral conductor is grounded at multiple points along the circuit. The size of the grounding conductor should be sufficient to carry the fault current. The NEC provides tables that specify the size of grounding conductors based on the size of the ungrounded conductors. The location of the ground rod should be chosen to provide a lower impedance path to ground. In general, ground rods should be installed as close as possible to the electrical equipment being grounded. Fourthly, let's discuss overcurrent protection. Overcurrent protection devices such as circuit breakers and fuses are used to protect electrical circuits from overloads and short circuits. They are an essential component of street lighting systems, preventing damage to equipment and reducing the risk of fire. When selecting and installing overcurrent protection devices in a public right-of-way, several factors should be considered. These include the ampacity of the circuit, the interrupting rating of the device, and the coordination of the devices. The ampacity of the circuit is the maximum amount of current that the circuit can safely carry. The overcurrent protection device should be sized to protect the circuit from overloads without causing nuisance tripping. The interrupting rating of the device is the maximum amount of fault current that the device can safely interrupt. The device should have an interrupting rating that is high enough to handle the available fault current at the installation location. The coordination of the devices is the process of selecting and setting the overcurrent protection devices so that they operate in a coordinated manner. This helps to ensure that only the faulted portion of the circuit is de-energized during an overcurrent event. Finally, let's discuss documentation and record keeping. Proper documentation and record keeping are essential for the safe and efficient operation of street lighting systems. Documentation should include drawings, specifications, and test reports. Records should be kept of all maintenance and repairs performed on the system. When documenting and record keeping electrical installations in a public right-of-way, several factors should be considered. These include the accuracy of the information, the accessibility of the information, and the security of the information. The information should be accurate and up-to-date. Drawings and specifications should be revised to reflect any changes that are made to the system. The information should be easily accessible to authorized personnel. Drawings and specifications should be stored in a central location where they can be easily retrieved. The information should be protected from unauthorized access. Access to drawings and specifications should be restricted to authorized personnel. In conclusion, electrical installations in public rights-of-way require careful planning and execution to ensure safety and compliance with applicable codes and regulations. Street lighting pole boxes and related equipment must be selected, installed, grounded, and protected in accordance with the NEC and local utility requirements. Proper documentation and record keeping are essential for the safe and efficient operation of these systems.